Hello and welcome back to another video. In today's video, we are going to talk about a one-way ANOVA. And a one-way ANOVA is very similar to t-tests. So in a way, this is just an extension of what we've already talked about with t-tests, but there are some unique differences and ANOVAs allow us to do a little bit more, which you will see in this video. So let's head over to the video now. Our next question is, does systolic blood pressure differ by gender? So we need to know, is this an independent samples t-test? And so we're going to run through our checklist and we're going to go to the next slide here. So we're going to think through our options. It says to check your variable first. And so our first variable, that is the continuous variable, is of course the blood pressure. And then we have our categorical variable with two categories. But in this case, we're going to go back and we're going to take note of our little clue that says to look at the variables for the categorical variable. So we're going to go back to our data set and we're going to check that out. So let's head over there. We're going to go over to our values and click on that. And we see that this has 3 values for genders. We have 1 for men, 2 for women, and 3 for non-binary. So this study is including 3 different genders. And so we actually cannot do a simple t-test. So for this, we have to use what's called a one-way ANOVA. So our t-test and ANOVA are very, very similar. T-test, we are going to use a continuous variable and a categorical variable with 2 categories. But a one-way ANOVA, we have a continuous variable and then we have a categorical variable with more than 3 categories. And so in this case, because they're classifying gender as 3 different categories, we are going to use a one-way ANOVA. So let's go ahead and look at some of the important things that we need to understand about one-way ANOVAs, and then we'll run it through our SPSS. Let's first look at what ANOVA stands for. So ANOVA stands for Analysis of Variance, and so you can see that at the top of the slide. But we typically just refer to it as ANOVA. So then the next thing we need to understand is that we are still looking at means, just like when we were looking at a t-test. A t-test is comparing means. ANOVA is also comparing means, but 3 or more groups, and it's comparing them all simultaneously. It also analyzes the variance between the groups and within the groups. So there's visual for that that'll show in just a minute. And then finally, we can do hypothesis testing with ANOVA. So we see here that our null hypothesis, we set all of the means equal. So remember that mu means mean. And so the mean of, in this case, we're just looking at 3 different situations. Let's say we're looking at the mean height of different plants. So this type of plant is the mean for plant 1, the mean for plant 2, and the mean for plant 3. And our alternative is that at least one of those means is different. Here's just a quick visual about what we were just talking about. So here we have those box and whisker plots, which you may be familiar with. First, notice that all of them are assuming a normal distribution. So that is one important characteristic about ANOVA, is that we do assume a normal distribution. But remember, the length or the size of the box is referring to the variability. So they're all following a normal distribution, but notice that these 3 over here, there's a lot of variability within each group, and these little shorter boxes, there's not as much variability. But what we're going to be looking at, what we're comparing, are the means within each of those groups. And so we are comparing the variability within the group, and we're also comparing the means among the groups. And the next thing to remember is that just like in our t-test, we used that t statistic. In this test, we are going to use what's called an F statistic. And this is what we are going to use to determine if there is statistical significance. ANOVA also has distributions, so let's take a look at the distributions. Notice there are several types of distributions we can get within an ANOVA, and they will vary by the number of observations as well as the number of groups. Now that we have all of those conceptual things out of the way, let's go ahead and run an ANOVA in SPSS. So the first thing we need to do is check our variables, and we have one continuous variable, which is the blood pressure. We're going back to that original question down here, is how does systolic blood pressure differ by gender? So just to reframe our thinking, so we have our one continuous variable, which was systolic blood pressure, and we have one categorical variable with 3 different categories. So let's go ahead over to SPSS and run this. The first thing we are going to do is go up here to Analyze. Then we're going to go to Compare Means and Proportions. Then we're going to go to One-Way ANOVA, and then we're going to click on that. Then this box will pop up. And now we need to remember what our dependent and independent variable is. In this case, blood pressure is our dependent variable because the blood pressure will depend on the gender. That's what the question is really asking. So we're going to come down here and we are going to find that systolic blood pressure. Hopefully we're getting quicker at finding that. Move that to the dependent list. And then we're going to put our genders over here. And then in this case, we actually need to click one more thing, and that is that we're going to go over to this post hoc. So we're going to click on that, and when we click on that, this box comes up, and we're going to go to this Bonferroni. And this Bonferroni, the reason that we do that is because this will adjust our p-values when we are conducting more than one or multiple hypothesis tests. And that will help us reduce the risk of getting a false positive. So now we are ready, and we're going to click Continue. And then we'll click OK, and then we get our results. So let's go ahead and look at a couple things. We see that our significance is 0.957, which is almost 1, and so it is definitely not statistically significant, right? So we still want that 0.05 for significance, and we do not have that there. So this is not significant. But if there was a significant difference, we would go down to this and we would look at this table. And this would show the mean differences and statistical significance between each pair. These are our pairwise groups over here. We can see that the significance level is set to 1 for all of them. So in this case, we would say that no, systolic blood pressure does not significantly differ by gender. All right, hopefully that video helped you to see when you would use a t-test and then to think about when it might be more appropriate to use a one-way ANOVA. And I look forward to seeing you in another video very, very soon. Bye for now.